Okay, so welcome to the Radio Telescope Observation Parties, March edition. Things that are going on at Sarah. Western Conference is the 17th to 18th of March in Bishop, California. And we do have, please sign up remote. Just go to the store and look up Western Conference, and then there's a one you can do for a local, which is about $55, and $15 for the online version of it. We'll be doing it real time, and then later on we'll post the YouTube video of the event. But it'd be nice to have you guys on real time. We'll have a lot of good presenters, and then I think especially we'll have the STEMSAT, a bunch of STEMSAT students that'll be giving videos. And Jay and I were just talking about the ability of us to take video of the Owens Valley antennas. We're going to have, when we get there, we're going to have to figure that out, and whatever the tours that we could take videos of, that probably won't not be real time. It'll just be the presenters will be real time. It'll look just like this, but the when we actually get to any touring or things like that, or going out to the antenna farms, we may or may not be able to actually video any of that. But if we can video it, we'll probably put it on our phones, and then I'll edit it into the final YouTube video later. Yeah, let's see. I'm not quite sure of the when the proceedings will come out. Anybody who signed up for the online or the local event will get the video link, but for the proceedings, but you won't get it unless you've signed up or paid your little $15 for the online. So just remember that if you want to see the proceedings. The other scheduled events this month, obviously Drake's Lounge on the third Sunday, and Drake's Australia, which is the following Friday, which is Friday U.S. time, but Saturday morning Australia time. That's been going very well. Those guys are very fun to talk to. They've got their big antennas are doing hydrogen, but they're having the same problems we have had on hydrogen, and I think that we're really helping them out a lot in terms of big picture, because we got a little more experience. They've also got a very active solar group, and so I think that's very fun. Let's see. On our let's see, we do have a Super SID group that has been doing the listserv, and if you look that their main concern is obviously getting the Super SIDs up and getting them talking to the database at Stanford. So there's a lot of that, and what is the setup for that? And they've also, that group has seen an X2.2 flare this month. That's also in listserv. The big talk on listserv is obviously has been masers. Edward Mole has put out a list of bright masers that looks like it's possible with a 3-meter dish and above. And there's been a lot of talk about, what is the signal strength of the maser? How much could a 3-meter dish do at the various frequencies? And so Steve Olney's had a lot of conversations on that. Michael Clauser has also shown that he's detected W51 at 22 gigahertz, a maser. Let's see. Alex has put out another picture of of doing his drift scan of the Milky Way with his hydrogen antenna. Looks very cool. Ted Cline has obviously put out his series on easy radio astronomy software. If anybody hasn't at least seen part of that, I'd recommend, I especially like the plots part, because it shows all the different types of products you can get out of detecting radio astronomy. And I think that's one of the things is we got a bunch of engineers who like to say have detected it, We need more radio astronomy analysts to say, okay, what have I detected and what does it mean? And a lot of the stuff on the masers is you get the two bumps, and that can actually tell you the blue and red shift and tell you almost the distance of the nebula or whatever of the physical object, and some distance information. So that, knowing that stuff, analyzing the data is as much fun as collecting it. Okay. And BAA, the British Astronomical Association, which we're closely tied to, did have a March 3rd event. I think now it's on their YouTube channel on Jupiter and muons, which is good. They've got a whole YouTube channel. I highly recommend going to them and looking up. They've got university professors and all sorts of people that have been given high-level briefs for the BAA Society there. Okay, Jay, Mr. Vice President, what else do you got? And you got any more on the Eastern Conference?
Thanks. If I can share a screen, I'll do that and see if I can bring up, well, I had it right here and it's managed to disappear on me. Let me try it again. Well, my share screen is giving me everything but what I want. So one more try.
It's coming up. There you go.
Yeah, sorry to waste everybody's time here. Let's see if this does work. Well, at any rate, what's that?
I'll edit it out.
Yeah.
Don't worry about it. This never happened.
So is anything showing useful now?
You have to unshare that and share your window with your PowerPoint.
Yeah. Let me just talk about it. The annual or Eastern Conference will be in Green Bank, West Virginia, Sunday, August the 20th through Wednesday the 23rd. We have some rough details that are currently posted at the website. We wanted to wait until after the Western Conference was over before we started sending out too terribly much on it. So wait until after the Western, and then we should have plenty of information available online along with conference registrations. We are looking for presenters. This will run pretty much the way Western is running. It'll be a combination virtual for online participants, as well as in person for those who can make it to West Virginia. We have on-site rooms available for 16 attendees. Generally, those are taken up by any of our VIP invited guests, the officers and speakers. That generally takes up the 16 rooms. There are no first class nearby hotels or motels, but there are acceptable quarters nearby. And for about a half hour, 45-minute drive, you can get very good rooms in nearby towns. So all that information will be available on our website right after the Western Conference is over. So again, we're looking for abstracts. If you could go ahead and think about things you would like to present, get an abstract in. Rich and I then can block out time for your presentation. That's really the reason why we do abstracts so early, is we're trying to get the schedule worked out. If we have, generally the way it works is Sunday is devoted to arrival and registration, informal tours of the site, and in the afternoon, a beginner's program for radio astronomy. Ed Harfmann has generally presented that for us, and I believe he'll be able to this year. But Sunday afternoon would be dedicated to a beginner's intro, followed by hands-on at the 40-meter, the historical 40-meter radio telescope, which between Ed and Skip Crilly, generally is a very exciting and informative time. And once you have been through the introduction to the 40-meter, then for the rest of the time you're at Green Bank, you're welcome to go and use it on your own. Just coordinate the time with the other people who might be there. It's very informal, but the building is left open for us, and you can just go in and use the 40-meter dish for whatever experiment you want to do with it. That means our normal conference proceedings would occur Monday morning through Wednesday, and we have the site booked all day long on Wednesday. So if we get a lot of presenters, Wednesday can be filled up. If we have fewer than expected, then we will close the conference at, say, around noontime on Wednesday, and the rest of the time is yours. You can go back to the 40-meter, you can take walking tours of the site. The afternoon can be very productive, so I would encourage everybody to plan on being there through the end of the day on Wednesday, whether or not we have formal proceedings on Wednesday afternoon. So any questions, be glad to answer them. Otherwise, we have an announcement in the current version of the journal and an announcement at the website, more details about the 1st of April. Any questions? I guess that's it, Rich.
Great. Hey, Jay, in the past, people have brought their small radio telescopes and set them up on the back lawn. I highly recommend that too. If people can, if people are going to show up, bring something to show off a little bit, and we can have that, maybe have a group out there in the evening after dinner or something.
Yeah, it's a wonderful time for show and tell. Good opportunities right after dinner while it's still daylight to set up. It's recommended if you have sensitive equipment, go ahead and bring some kind of rain protection for it. Some people just throw a tarp over their stuff, but it very frequently rains back there late in the afternoon and evenings. We have not a lot of overhang space from the building, but outdoor exhibits are good. And traditionally, one of those has turned into a swap fest. 2019, there was some pretty good things there. And I believe Steve Zekas brought an exceptional library that was available for swapping for stuff or very low cost. I picked up a lot of good books from Steve last time. So if you have things you'd like to swap, trade, give away, that's a good chance to get it into good hands.
And I believe normally there's I'm not calling it the wives group, but the significant other group who came along with the radio astronomy people that don't want to go to the conference, but we normally we'll have somebody there that will organize tours, I guess, into the local areas. There's some really good places to go tour around, I think, on that area.
Yeah. And I think very often Charles Osborne's wife was one of the ringleaders in that. I think Charles is online. I'm not sure if she would be planning on coming this year, or if Charles or she would have recommendations of who we might ask to put that together for us. But usually there's a lot of good things for people to go see, other family members who come who are not involved in the conference. It's a historically interesting place. I know, among other things, Pearl Buck's house is not too far away, and a couple of famous lodges. So I'm not sure if Charles would like to take a minute and address what the spouses have done and whether he's thinking his wife might come this year.
Well, it's all dependent on the COVID restrictions, whether they follow through on forcing that or not, because she's not vaccinated and won't be. So she is not coming if that's a requirement. So the wives have, historically gone a variety of places. So like down to the Greenbrier to do that tour. In fact, we've gone up to there's some caverns nearby that are worth seeing. A lot of different type things going on for just shopping type stuff in the nearby towns. So there's quite a bit of stuff within an hour's drive. Down at White Sulphur Springs, Elkins, different, all the little towns around there have thrift stores and antique shops and stuff like that. So they've made the rounds on that kind of thing. So usually it'll be like 6 or 7 of the wives will get together in one van and make the rounds to some place that they haven't seen before. So kind of depends on who's going and what they want to do. There's a Cass railroad trip. That's another fun train ride to the top of a mountain and back down. That's kind of an interesting way to spend a few hours. I don't know if there's anything up at Snowshoe that's a good reason to go up there when there's not snow on the ground, but that's another area nearby. So yeah, there's a lot of stuff to do, and also I get a lot of things from the county up there. So I forwarded that link to Jay, and I think it was in the journal or on the website. So that's another thing to look at, see what's going on in terms of festivals and things. But there's not as much right around that time of the year for some reason. I think it gets later in the fall is more common for the fall festival kind of events.
And Charles brought up the issue of COVID restrictions at the site. As of last week, they had relaxed all COVID restrictions except for individuals with symptoms. So people with fever or testing positive are restricted from coming on the site. But otherwise, there are no mask requirements and no vaccination requirements. It's recommended, of course, but not required.
All right, so they dropped that. That's good to know. Okay.
Great. That's good to know. All right. Thanks, Jay. Dave Westman, did you just pop in? I saw David. I wasn't sure if that was Dave Westman or not. Okay. Let's see. One of the major contributors to YouTube this month has been Ted Cline. Ted, not to give a presentation, but just to go over what are the YouTube videos and what are the other things that, like the GitHub site and all that kind of stuff, people can sort of aim at.
Okay, I get another chance for an ad. I wrote some software. I offer it to everybody. It's certainly been advertised as well. There are some videos to try to tell you how to use this complicated thing up there on the Sarah YouTube website. And there are 4 from me and 3 from me and Pablo. And so we got some examples there if you're willing to stand it and sit there. You're welcome to throw tomatoes. That's just fine. And then there's a 5th one that I've produced and is coming real soon, all about filtering. So capabilities. The next one after that should be quick, which is about actually finally putting these things up on sky map so we can see where these images show up in the sky. So fun stuff coming. Have fun with it. I do have some pictures to share. So let me try that. Not about Ezra, much more fun stuff. The trick will be finding it. Let's try this one. Yep. All right. Hopefully you're seeing something.
Okay, there it is.
Up in Estes Park, the high school students had a project probably 8-9 years ago and put up a 10-foot dish. It's beautiful. It's right outside the Estes Park Memorial Observatory, which is about 30 feet from the football field. I'm always surprised this thing isn't filled with footballs. In any case, it had some trouble. Apparently, it's been windy up there in Estes Park, and this poor fellow has changed shape now. One half kind of disconnected and fell over and got folded. So it's not the same dish as it was, although it was suggested that it might have a very high gain now. So that's a possibility. It's still all metal, so that's all good. Let me zoom back out, show you yet another picture. I guess that's about the same thing. Here's one from a little more from the side, and it's just not the same as it was. So what would I'm actually asking, what would I put up there instead of such a large dish that might survive the winds? A Yagi, one of these disc Yagis maybe, a scope in a box kind of product, and still use the motors, but maybe not just let it survive longer. Although 8 years was a nice run. Anyway, I'll take this horrid thing out of your view now.
Do you know what kind of wind they had? How much wind there was?
It was quoted 65 miles an hour, so it is kind of breezy there. There's so many hills and such, it could have been amplified beyond that. It might have had age on its problems list. So
steady 65 would be gusting to 80 or 90.
There we are. The thing survived this long.
Right. One other thing, Jay and Ted put out an email with somebody's been offering a large telescope, optical telescope. I don't know if you want to show, Jay, if you can show that, or Ted can show that. They sent it down to Colorado Springs. Nobody here has the ability to do this, but I'm just wondering if anybody online would know somebody that would want. And this isn't your little telescope stuff. It's a big one.
Yeah, I think it has a 32-inch mirror. It'll take me a while to find those pictures. Ted may have them closer by. I'll dig them out here so we can show them before RTOP ends, though, if Ted doesn't have it.
Yeah, if anybody wants one of those things, you have to provide your own shipping cost, obviously.
Yeah.
But
yeah, free for taking. Free for taking. You just have to get it.
That's right. Okay. We go on here. Wolfgang, what's going on with your projects?
Well, the main thing these last couple of weeks were still continuing on the FRB observations. The FRB we've been observing for the last 3 months or so. We essentially stopped by the end of February because it more or less has become silent. We had a last run of observations actually simultaneously with Effelsberg and the submillimeter telescope on the Pico Veleta, and actually it's run by French and Spanish astronomers. So I haven't seen any definite results, but we didn't see anything on that particular day. So it looks like this FRB has gone quiet. So we are not spending much observation time as of beginning of this month. So we are looking what next to do. We have for the upcoming days, we have a couple of training courses with students, so that will essentially cover our observation time. We haven't done much with the small dishes recently, mainly because we are sort of doing a cleanup of all the stuff that's lying around and being in shells and so on. So to get rid of some stuff that sometimes has to be done. So that's what we're working on. I think there's not much more. Maybe we can talk about the mesas a bit. You asked whether we want to talk about it. We can do it right now, or maybe do it later.
This is fine if you want.
Yeah. Okay. I have to say that our own observation efforts with mesas have mostly been with OH mesas at 1.6 gigahertz. So essentially 1612, which are the typical circumstellar mesas, and 1665, which typically found in star-forming regions. These circumstellar mesas, we are doing a very regular observations there. About every 6 weeks or so, we scan through a number of specific mesas to see their long-term development. We started that program maybe 4 years ago. So every 6 weeks we get a set of data. That's all done with our 25-meter dish. If you want to do OH mesas with smaller dishes, that's quite doable, but there's of course much fewer mesas that you can observe. There are essentially 2 major ones which can be observed fairly straightforward. There's been quite some discussion about water mesa emission. We haven't done much with it yet. With water mesas, these are at 22 gigahertz, what we have done with our 10-meter dish. But the people in the Netherlands, Edward and what's the other guy?
Michael
Anyway.
Clausen?
Yeah, no, Michael's also from the Netherlands, but he's using a larger dish. It's Job and Ed, those
yeah.
two. They've done some very impressive things. I think the latest that really impressed me was a water mesa with a 1-meter dish, which was transiting through. So just he had a series of shots where you could see the mesa line coming up as the source went into the beam and then drifting out again. I found this very impressive. One has to say that water mesas, they can be extremely bright when they are flaring, but you never know when they are flaring. But I think this is a very worthwhile thing, and I'm really, really impressed of what is done with these small dishes on water mesas. And the same goes for methanol at around 12 gigahertz. Also, we have done a little bit work, but not much. I'm hoping to increase our methanol and water mesa activity sometime later this year. But again, I think the most experience you have from Ed and Job in the Netherlands. Unfortunately, they don't join here. But if you want to know something about it, I think those are the 2 guys that can be asked. As far as receiving is concerned, the OH mesa at 1.6 gigahertz, typically your gear that works for hydrogen will also work at 1.6 with some degradation probably, and obviously you need to have a different filter, but other than that you can use the same dish, obviously the same low noise amplifier typically, and the same back-end gear. 12 gigahertz for methanol is also fairly straightforward because you can use standard LNBs, just the ones that use for TV reception. If you choose to do that, typically you would choose to take a PLL type LNB, because then you can feed in an external reference signal so you know exactly what your frequency is. 22 gigahertz is a bit more tricky, because there are not that many LNBs around that work at that frequency range. There are some for Ka band, but you're stretching them a bit because your water masers are slightly above the typical Ka band LNB, but some of them work. But they're hard to come by. Another difficulty or challenge is with the LNBs at 22 gigahertz, typically they are not PLL type. So you have to inject a direct LO signal if you want to have an exact frequency. I think what Job and Ed have done is that they just let it run freely, and they monitor the frequency by looking at satellites. So they compare the frequency to known satellite frequency, then they know how far off they are. In our case, in our receiver for 22 gigahertz, we're actually injecting a local oscillator signal directly into a modified LNB. So that's a bit of an effort to do that. In summary, I would say masers are really worthwhile looking at because they are variable sources. You can see how they develop, how they change over time, and they change in fairly short time scales. So that's what makes them interesting.
A couple of questions on masers that have come up that I'm also interested in is the what is a maser? I mean, what is the physical phenomenon that causes it? Can you obviously the big question is, can you see a maser with a 3-meter dish? Can you, does it have to be drift scan? You have to have a tracking dish. And what is the, you know, I've noticed a lot of these things have double bumps on them, which you can, you know, one is the front end of the thing toward us, coming toward us, and the other's away, which means it's sort of the thing blew up somehow. It was like a nova or something that caused it to expand. That's sort of the questions I've had on some of this.
Yeah. Let's start with a physical process. Let's take the OH maser as the most prominent example. The transition that you have is just like in the hydrogen, it's a hyperfine transition. The difference is that in the case of the OH, there's a rotational motion, which is a certain energy level, and that is split up. Maybe if you, let's do the following. I have a couple of slides which I need to find, which can explain both the double peak and so on. If you give me a few minutes and I will come back. In the meantime, I'll look on my disk where to find it, and maybe you can discuss a few things in between while I'm looking for that material. Is that okay?
I think that's great. Jay and Ted, I think, found this picture of this 32-inch telescope. So Ted or Jay, do you want to show that thing off and see if there's any people want to get a free giant telescope?
Yes, I believe I'm showing it.
Yeah.
So this is a 32-inch, very, very heavy telescope. As far as they've described it to me, it does come with this mount, but it is not, there's no motor drive or anything connected with it. It's just a physical mount to keep it up off the floor. We're looking at tonnage. So this is not for the faint of heart, I guess. It was offered to Little Thompson Observatory, and it is beyond our ability to deal with something of this weight and size. Far as far as we've been able to tell, it is set up as a Casa Green. It has a small finder scope on the side, which even of itself is a rather large refractor. But if anybody is interested in this, I will send you a link to the company that has it. They purchased it for a defense contract. They were doing very fast tracking of objects in orbit. The contract is now over with, and they just need it out of their warehouse. So as far as we've been able to tell, it is free for the asking if you have a big truck.
It looks like it was made by DFM Engineering, probably.
Yes, indeed. It is DSM.
Okay.
Does that mean you want it? We'll be glad to ship it FOB, COD.
No, it's similar to well, DFM Engineering did a lot of the telescopes up at Perry, including the 85 footers, as far as the motor drives and software and stuff. So I know Frank Melsheimer is that's his company, and I know some of the people that work there, but I assume it's not at that company. This is one somebody else bought at another company.
Yeah, another company got a defense contract and bought this from Melsheimer.
Yeah. I have no. There's no way I could get that. That's for sure. Yeah.
There's an organization called Uber Truck that you can call, and they'll come and pick up a load for you as long as you can load it within 2 hours and take it wherever you want to go with it, as long as you can unload it at the other end within 2 hours.
All right, so I don't see any Preston's already been vetoed by his wife. I don't know, Preston. I don't know who controls the household there, but I don't know why you can't have it. Okay, Wolfgang, are you ready, or is that long enough?
Yeah, I'm ready. So let me try to share that. So I need to make that full screen. Oops, I have to quickly go through a couple of slides. Okay, the annotation is in German, but I'll explain it. So first, just a few slides on the very basic principle of the maser. So typically you have any molecule or hydrogen or so with different energy levels, and typically they are in an equilibrium, which means that the higher energetic levels have less population. So the population is depicted here. This is what you typically find in what is called a thermal equilibrium. Now, what can happen if you have a strong radiation, that some of the material that's in the lowest energy state is pumped up, so the population gets higher. So if a resonant frequency, so this gets populated. And that leads to a situation where actually there's a higher degree of population compared to, for example, this energy level. And this is then the case when you have can have a maser radiation, so you get an amplification. Now, coming to the OH molecule, this is just a picture of what are the different rotations on. Just let's skip that. The basic message here is that in the fundamental rotational state, you have a splitting of this level to finally 4 different levels. And these 4 levels are the ones that play a role in the OH maser. So what happens is, if you are in an environment where you have strong infrared radiation, anything that's in these lower levels is pumped up into a higher, what is called a vibrational level. And that decays very quickly, and as this decay leads to a overpopulation of these higher levels, which are depicted here, and then maser transmission or maser emission can occur. Oops. Between these levels. So in an OH maser, in an OH molecule, you can have 4 different maser transitions at the frequencies of 1720, 1665, 1667, and 1612 megahertz. The most important ones are the 1612 and the 1665. So what are the ingredients to get maser radiation from OH? First of all, you have to have OH. So some place where you have molecules. The second thing that you need to have is strong infrared radiation, because you need to have the energy source to bring it up into this excited level. So you need to have an area where you have strong infrared radiation. And then the areas where you have high infrared radiation, these are star-forming regions, H2 regions, and infrared stars, or big. These are the big, very large stars which have a strong infrared radiation. Typical thing that happens, these are just a few examples of the spectra. This is the OH, W3OH region, which is a star-forming region, and you can see an emission at 1665 there, and a weaker emission at 1667. And this is an example of an emission from an infrared star. And this is where you have this double peak. This is both the 1612 transition, but it turns up at 2 different velocities. And why is that? It's shown here. So what happens is you have your infrared star, and these big stars, they have material flowing away from the star. So it's flowing away from the star, depicted by the green arrows. And the material that's flowing out, that does contain, among many other things, it contains OH. So you have OH, you have the strong infrared radiation from the star, so you get maser emission. And let's assume you are the observer sitting here somewhere far away, but in this direction. Then you would see emission from an area, see emission from an area where the material is flowing towards you. So that is blue shifted. And then you have another area where the radiation is also coming towards you, but the material is flowing in this direction, it's flowing away from you. That's why it's red shifted. And therefore you have a red shifted and a blue shifted lines. And this is very typical. So if you see this double line, that's typically from an infrared star, where you see the material flowing away from the star, giving rise to the 2 different Doppler shifts. So if you look at the spectrum, you see a shift. In this case, it's red shifted at about maybe 20 some kilometer per second as an average, but then there is a difference, the blue shifted and the red shifted. And this difference here is the velocity of the material that's flowing, and this is the velocity of the star itself with respect to yourself. So this is essentially what can be observed. What you also, and this makes these OH masers interesting, they are variable in a cyclic manner. So these infrared stars, they have increasing intensity and then decreasing intensity, and that's also reflected in the maser radiation. And if you observe them for a longer time, you can actually see these activity curves. So this is basically the physics behind the OH maser. Let's see, I may have, that's a bit of the gear that's shown here. This is a standard LNB that's used there, which has been modified. Maybe no, I'm sorry, it's not showing the inside. I was just quickly picking that up. So it's essentially an LNB, and we inject a reference signal at 25 megahertz for the internal PLL. Yeah, that's what I can share quickly. I didn't prepare anything. That's just picking out some slides that I had from a different presentation.
Any questions? Now, can you do you have to track on these things? Can you just drift scan through them?
If you have a 3-meter dish, you would need to track the OH. It will take you maybe a half an hour integration time. So that's probably it's not doable doing it just by having a drift scan.
Okay. All right, any special software that you would need?
No, it's we are using exactly the same software as we use for the hydrogen, just at a different frequency.
Okay.
So
Right.
I would assume, I'm not sure what the flexibility would be from Ted Cline's software, whether it can be used for 1600 megahertz range.
Sure, just change the numbers.
Yep,
Thanks for your
yeah.
information too, because that's helpful.
All right. So Ted, we want to see if we get a maser. It'd be fun.
I'm all for it. Sounds great.
Yeah.
I want success stories.
And before we move on, I really want to thank Wolfgang for that explanation. You know, we've had quite a few presentations through the years on masers, but none was that clear in explaining exactly how a natural phenomenon can do something that most of us think could only be generated in a laboratory. I've never seen an explanation that even came close to being this clear. So thanks.
Yeah, maybe just one side remark. Typically, when you talk about lasers, you think about something that's between mirrors, or you have a resonant cavity when it comes to masers. So people asking, well, where are the mirrors? There's no mirror needed. Essentially, the reflecting surfaces for a maser, or the mirrors in a laser, the purpose of that, making sure that the beam travels many times through the medium. Now, in astronomical masers, you don't have to travel back and forth. It's just long enough so you get the amplification length easily without reflecting back and forth. So that's what makes them different. And it's, in a way, it's amazing that these masers do exist, and they're quite frequently found in not only in our own galaxy. If you have a bigger dish like the professionals have, they can see masers in other galaxies as well. There's a lot of work being done with interferometry on masers in other galaxies, but that's beyond our capability.
All right. Okay. And it's good to know that the best explanation for masers was in German. That's great. All right. So yeah, pull out a couple other your German articles, and we'll go for that again for something else. Let's see. Alex, you got anything going on? Any more modifications to the scope and the box stuff?
Yes, I do. And I have a little mini presentation I want to start.
That's great.
Share. Maybe. Is it working?
We see umbrellas.
Okay, umbrellas. I guess it was a month ago when someone brought up, it may have been Bob Strickland, about using photo reflector umbrellas for radio telescopes. And that seemed like a really great idea. And so I've been pursuing this over the past couple weeks. And so the idea was, well, let's see, how come that's not? Yeah, was to see if I could come up with something that was on the scale or lighter than the scope and the box system. Try to keep the price down, but to but to optimize the performance of something that is actually tuned to a 21 centimeter. And here's the problem. So I tried, I bought a bunch of these. I bought 4 different brands, and each one had a different type of reflective material. And one was probably bright enough, you probably could have cooked hot dogs in the sun off of it. And they all worked really well with daylight. The problem is, at 21 centimeters, the reflective material just basically disappears. I held up I took my my loop feed and put it on the VNA analyzer, and as I brought the reflective material near the loop, it detuned it. So I thought, okay, it must have some kind of useful RF properties, but it didn't. I just put it outside, and the only thing I measured was the temperature of the ground. So that started a big project. This is like, what can I do? Well, I tried putting up some aluminum foil. That was just nasty. That was something that no one would ever want to try to do. And the goal of this is to build something that maybe someone else would want, a scope in the box-ish type thing, and that wasn't it. I don't know how I came across this, and I don't know if anyone is aware of this, but there's an incredible material out there called Faraday fabric. It's thin, it's flexible, it has it's a polyester-based material, but it is conductive. It is conductive through from the front to the back. I had about a square meter of this stuff. There's only about a half of an ohm loss from one end to the other. It's phenomenal, and it is reflective. There's all kinds of, most of the people use them to build protective clothes for themselves, to protect themselves from their cell phones or whatever. But this really is a very reflective and flexible material. So I covered the inside of a 1 meter parabolic photo reflector with this stuff. And that was pretty easy, spray on contact cement. I probably could do it better the next time, but it's sort of a proof of concept. And to match that, I made a small tune loop feed. And the goal of this was, the one that I had on my website or had presented there was a lot of work involved. I wanted to build something that was almost effortless. And so the pan is not cut down. It only requires 2 holes, 1/2 inch for the center and 1/4 inch for the feed through. And you mount the Sawbird to the dish, the cake pan, and a little F connector, SMA to F, gives you the inch standoff required for the loop feed. And so this actually works out pretty well. Just make a little loop out of like 18 gauge wire or the center conductor of RG6 cable and solder that to the center pin, bring it around and put a little flat side on this and solder it to the other. So this was a really simple system, and it's a tuned antenna feed. And so this is what it looks like operational. And it's easy to set up. All you need is stick a pipe in the ground. It had been really windy over the past couple days, and so I used little tent pegs and guide it off. And I ran 9 or 10 hours worth of tests yesterday with it. And this is some ideas of what it looks like. Between the calibration cover and the cold sky, I got a delta of 4.2 dB, which isn't too bad. My system, I get between 6 and 7, but considering this thing really isn't a parabola, I was pleased that I got this much of a level difference between this. And this was taken early in the morning, way beyond outside of the Milky Way. So this is a pretty good base look. And as the 40 degree, 20, 30 hour sky drifted through, I got that. And it's about 1 dB above cold sky. See, I don't know how this compares with the scope of the box. These are 5-minute averages. I took averages parallel to what I did with my scope in the box variant, so that I had a good comparison. That this is what it looked like in real time, and this is what it looked like when it was plotted. There's a lot of background drift, but normalizing that out, this was like I don't know, whatever that comes up to be, 9 hours. I got a contrast from cold sky peaked out about 1.1 dB, which wasn't really too bad. And plotting it in my contour plot, it's reasonable. And then I ran this through a 3-point filter, and it looks like this. And that's really not all that bad. Like I said, I don't have a scope in the box. I may go back and deconstruct mine to compare, but this is with this little $60, $65 photo umbrella, and this is with my more refined system. But I mean, this cost about 8 to 10 times what that did, and this thing you can set up in like 5 minutes. So I was pretty pleased. I think that's about it. Yeah. So the question is, how well does it work? Is this a viable solution for beginners? You need to drill a couple holes in a cake pan. You don't need to cut it down. 2 solder joints, and do some contact cementing of this reflective material into the parabolic dish. What you think?
I love it, Alex. I think that's great. And in fact, I have an umbrella already, but it's not metal, and so that could be used right away. That's kind of neat. I'm curious, how many cake pans have you bought so far? Well done.
Umbrellas?
Cake pans.
Oh, I have a whole bunch. I have a whole bunch of them because I've tried different designs. See what I did. This one is a small variation. Let me go back. Oh, let's share it. On my systems, I use a 5-inch cake pan, and I cut it down to 35 millimeters. I didn't want to, it's kind of tedious to cut these things down. So what I did was I bought a 6-inch. This is nice. This is not the Fat Daddy-O's. This is a different brand, and it's real aluminum. So you don't have this hard coat to take off. And so all you do to turn this into a loop feed is drill a hole in the center for guide point. And I came up with a fairly sophisticated machine part, but for the rest of the world, I think we can get by with a piece of lucite tubing and some nylon spacers and just glue it together. But this works out really well. So that's all it is, and it's really fairly efficient in that the LNA is pretty much directly coupled right to the loop.
Excellent. I was just thinking you were a favorite customer of the company, but now you got another company.
I buy a lot of stuff to test. The one photoreflector I found is a Westcott 45-inch, and it has closer to a parabolic shape than others. A lot of them seem to be flat and then out. The point that I found, I might want to try this a couple more times. I calculated the focal length should be 11 inches, and I think I have this sitting at 12 and a half. So it actually worked. It worked fairly well, and I just didn't go there. Because this thing has a little hose clamp on it, I could slip this down the shaft. And I did this in 1-inch steps and then in 1/2-inch steps, and then found the spot which gave me the best signal noise ratio. And that's what I ran. But does anyone know what a scope in a box, how that works? Is this equal to that, or how does it compare?
Should be pretty close to equal if the area is equal. How close to a parabola is it, Alex? Can you do some tricks with paracord to stress the panels?
There's all kinds of things that could be done to this. What I wanted to try to do was to come up with an extremely simple, minimal solution that worked.
Right.
And then how much does the 7mm steel shaft interfere? I don't know.
Not at all. The shaft won't
It
interfere.
didn't seem like it did much at anything. And so what I wanted there, it is open for modification or adjustment. But what I wanted to try to do is to come up with a design, a package that someone with minimal machining tool skills could build. And the nice thing about it, it's easy to take with you. And it folds up. I wouldn't completely wrap it back up with the straps, but you can fold it back down to this level. And so you can take your antenna with you, and it's weighs
Right,
2 or 3
Paul,
pounds.
Paul Allen has something like this at 1296 for a 23 centimeter umbrella thing. It's a little bigger, but several people have been using that for 1296 moon bounce. But I just wondered, because it would be relatively simple. The ARRL handbooks have had stressed umbrella shapes. That's a pretty deep thing. It's probably got your ring feed is good for that deep, for the deep dish. I think it could be stressed. It
It's
could be
about
very,
I calculated it's right about F28,
yeah,
up to D28.
right.
0.28. So,
Hmm.
but I have never seen a small conductive reflector. There was someone that sold maybe 2-meter umbrella types, but they were like $1,800. This is a 20-meter reflector and $20
Right.
reflector and $20 worth of fabric. So the whole system you put together for about 65, 70 bucks.
Oh yeah, no, that's really excellent, Alex. There's no question about it. I think just a few strings might even improve the
Could be.
shape just a little bit. It looks like it wouldn't have to be tweaked much to get what you want. I think it's great, absolutely great.
If you get larger, you go into 16 segments. And that gets a little tedious trying to manually line that many pieces. So the 1 meter looks like it's pretty easily doable.
Yeah, it's great. How's that fabric? Is it very expensive?
I said I'm surprised. It's about $20 a meter. And I mean, it's just a thin, but it feels metallic. I mean, you can see through it. It's almost like an ultra fine mesh, but it's
Right.
not a pure metal. It has a polyester base, but it is conductive.
Right. That's amazing.
Yeah,
Stuff.
I had never heard of this before. And you go out and you look at the comments on this stuff, and people are making drapes out of it to protect themselves from their neighbor's TV satellite dish. Oh, you got to read some of the comments of what people use this for.
I'll bet it's great. Looks like a good hat material.
Three laps around their cell phone, and a person could feel the difference in
Right.
radiation.
I'm sure. The thing is that the optical umbrella shapes don't have the skin depth at 1420. So, but this material evidently does.
It does.
That's
I mean,
different.
it's as good as aluminum. I mean, it literally is like a copper nickel mesh. And I mean, it's flexible, it's durable, it doesn't tear. So it's a very good product for this type of application.
I got another application for you. You should look at, Alex, and that's laptop interference into the 1420 receiver. Putting that
Yes.
fabric near the laptop to shield the laptop might be an interesting trick. I'm definitely going to buy some for a few things that need shielding that's flexible.
It's not my laptop. It's this bank 24-inch monitor.
Yeah.
My antenna will pick this thing up 50 feet away. Yes, I'm gonna buy more of this stuff. I've never heard of it, but I mean, there might be 15, 20 vendors out there on Amazon that sell this stuff, but it's beautiful.
What's the bigger sizes of it?
It's all about about a meter wide, and you can get it hundreds of feet long. I mean, you can buy it at about square meter and longer.
Neat stuff.
All right. I'm going to buy stock in that company. All right. Anybody else got anything for Alex?
Thank you, Alex. I think that's great research. That's what we want. Let's make it even cheaper.
Super good.
Now, just to ask the question, are there any more of those umbrellas that are, a 3-meter umbrella or any huge umbrellas that are available?
You can get up to 72. I might try one. I mean, it's gonna wind up being about $150, $160 worth of parts just to cover the inside. But yes, you can get them fairly large. It might be an interesting exercise to do it. They get pretty large, but you can get them. You can get the 72-inch reflectors are $100. So,
I guess the other question is, Ted, the telescopes you got with the mesh couldn't get 22 gigahertz because the mesh is too big. If you put this stuff on your telescopes, can you get to? Will this mesh work with 22 gigahertz for masers?
Yep. Should.
I don't know how this stuff would weather being permanently outside. I'd have to do a test on that.
Wind is the problem again.
Well, also because of the much shorter wavelengths, the accuracy of being deviating from a parabolic dish will probably not be a good reflector anymore. I mean, at 21 centimeter, you can live with much deviation from a parabolic form in the centimeters range. But if you're down at 22 gigahertz, you're in the 1 centimeter wavelength, and then the shape becomes much more critical.
So why does it turn invisible at 1420? Is it just skin depth and we're using such a lower frequency than light from the sun?
Oh, you mean from the for the original reflectors?
Exactly.
They're using a coated mylar. It's
so that's a thin coating, you're saying?
the coating.
We just need more skin depth?
Exactly. Yeah. This fabric evidently is thicker than, the coating is only a few molecules thick on that, on the reflective mylar stuff that's used. Think of the mylar balloons that you fill up and says happy birthday on it. That's that kind of fabric, and it's very, 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 very tough. The mylar is tough, but the coating is only a few molecules thick, which is just fine for light, but absolutely it's almost transparent, as Alex has pointed out, at 1420. So you need that skin depth to get an adequate reflection.
So
I guess-
Alex, you could put this fabric on the old scope in a box instead of aluminum screening.
No, I wouldn't. I lined that with a thin aluminum window screen. It's the window screen is much more durable. This stuff is too soft. It won't support. It would not support itself well in the grids. It's just going to sag. I mean, this is literally soft material. So it'll work against the solid background of these parabolic reflectors, but it's not self-supporting.
So what you'd need is the screen just to hold this stuff up, and
then you've got
you're doubling
you've
the
got
effort.
like,
And why? Yeah. Okay.
All right, any more questions? Alex, outstanding work. That's gonna be fun. I think you'll get a lot of, when we post this thing, we'll get a lot of people experimenting with that, I think. Let's see, Don Latham, what do you got going on? Any more feeds you've been building?
I'm waiting for the snow to get thin so I can work outside. Been cold, and it's been cold and COVID. So I haven't done much of anything.
Oh, that's right, yeah. Okay. That's probably a pretty good excuse. All right. All right, Bob, what do you got going on?
Oh, I'm working on several different projects here continuously. Hopefully going to have some of my additional cameras installed for meteors, and trying to get my SIDS antenna improved. And I've got power and network run to my observation location, so I'm ready for that. So just slowly sneaking up on it. The weather's gotten pretty here, so I'm working almost all day outside on something. So that's about it.
Well, I do want to ask you about the Super SID antenna, since right now I just got a loop, and I've just never heard any recommended modifications to improve the loop, improve the sensitivity of that. How are you thinking you're going to improve that?
So I've got an article that I found written by a guy back in 1969 who was trying to work at VLF frequencies on ham radio. And what he did was he basically put up a 1/2-inch diameter copper tubing with loops of wire in that. And I've got 16 loops pulled into that. And I wound a ferrite rod, essentially like a balun or a transformer to match the impedance. And I've spent quite a bit of time working with Spice trying to decide if I've got the best combination to get the best match for it. And I'm not convinced I do yet, but I've got my copper tubing laid out there, and I happen to have a hay ring that I put a bale of hay in for cattle. It's a right diameter, so I can use that to form the loop, the right diameter. It's got an insulator in the middle of it, so it supposedly reduces static charge, I believe. Anyway, I was going to try his idea and his loop. Now, part of the thing was his situation was he needed to be able to transmit too, so he was trying to match the impedance well for a transmitter, but I don't need to do that. However, the best match is going to probably be the same, whether it's being transmitted on or not. So I'm also actively involved in the HamSci project and been working with those guys. And there's one fellow there in particular that's trying to do transmissions at very low frequency also and receive those. I bought like an audio, you can think of it like a sound card that's a high resolution sound card that does, I think it's better than 196K sampling rate, 4 channels. And I was also going to put in 2 ground rods spaced about probably 100 feet apart. I bought the ground rods, and the concept there is you can hook 2 wires, one going off in each direction, a single wire to each ground rod, and you can pick up VLF frequencies in the earth. And I wanted to be able to do a differential comparison between the stuff I get in the loop and the stuff I get in the earth, because the loop is going to pick up a lot more noise, I believe, than the ground rods will. I think the signal strengths will be higher on the loop than the ground rod, but that's just some things I wanted to experiment with. I have no shortage of things that I want to try, and I'm one of these kind of people that's constantly building something and trying it, I guess, and not getting the data, and sometimes that's frustrating. Charles sent me some good comments on this. I need to spend more time just collecting data.
All right. Any more questions for Bob? Thanks, Bob. Yeah, I'd like to hear, you ever get that design sort of put on some PowerPoint slides? That'd be really fun to look at.
Okay.
All right, thanks. Helen.
I'm here, not a whole lot since, am I unmuted?
You're good.
Oh, okay. Not a whole lot here with all this bad weather. We just all got sick, so not much of anything happened in the last week and a half. But I did register for the conference, and I'm looking forward to that. That would be good.
Great.
Thank you.
All right. Thank you. Mike Ott.
Okay. I'm working with the local observatory with their outreach program, and they bought a scope in the box. So they put me in charge of putting this together and demonstrating it this summer. So that's what I've been working on. That's it.
Okay. Well, you got, obviously, you know who the experts are that been playing with it around on this channel here. So good. Ed, you said you didn't have anything, but do you got anything?
No.
Any comments?
No. I enjoy listening and the like, and I hope that one of these days I can get around to actually doing some of this stuff. And like, I wouldn't be too surprised if by the time I get to the point of trying something, I'll be able to pick it up with my cell phone. Have everything that small and that sensitive. But yeah, maybe not.
And in this picture, your grandson's probably in college now, and he's
no, he's about 4 now. So
okay.
He now has hair.
Okay. All right, thanks. Preston, I know you're you obviously can't get the 32-inch telescope. That's too bad, but what else you got?
Okay. I did a little study. I've been doing a little study on plasmas, and that's about it.
You got to add more than that. You've done a study on plasma. What is that?
What is it?
Yeah, I mean, don't leave this hanging here. What?
well, let's see. What I did was I'm kind of auditing a little course taught by a university out of Lausanne. I guess that's the way you say it, France, on plasmas, and looking at some of the math, not actually working it, but looking at it, and just getting an overview of what it is they're doing. So.
If you want to put a link to that university, that'd be great. Someone might want to do it too.
Okay. See if I can find it.
Thanks, Preston.
You're welcome.
Charles.
Yeah, no shortage of projects around here either, and the weather's been good. So we're not in the snow belt lately. So I'm supposed to be working on the garden, getting that ready for this year. But did buy one of the umbrellas like Alex did. Didn't get very far with it. I had the bright idea that I'd use my cell phone to find the focus and figure out whether the fabric was transparent, just trying to use it at Wi-Fi, and it didn't work out as a good test. It slowed the software way down. Some update did recently, so it wasn't nearly as useful as the Wi-Fi analyzer app that I had been 6 months ago. So that but anyway, the umbrella that I bought, it was inconclusive whether it was reflective or not. And so I see now from what Alex has done that the fabric needs to be that material that he got. So I'll probably get some of that and play with it. But let's see. And I've been working. Pablo sent me a link to a company called DaVinci Resolve software on doing the video editing. So that's a really nice program. Fairly involved. I can work on audio levels and things even with that. So that is a steep learning curve, but has lots of features. Actually had to. I started out with version 18 as the most recent, and found out that my Windows 11 computer, the best one I had here, wasn't new enough for that program to run on. So I had to downgrade it to a 2020 vintage version to get it to do the editing and stuff. Got that going. And then, of course, the monitors that are on that computer turned out to be the largest source of interference on my 1420 receiver. So that was not good. So now I can only really do that when the 1420 stuff isn't in a good prime galactic ridge type crossing. So yeah, these monitors are a real, well, in the computer itself. I need to figure out how to slow the computer itself down and try to move some of those 1419, 1420 spurs off of the hydrogen frequencies. That's, I don't know, has anybody played with that? Trying to move a PC frequency of the CPU around and to get rid of some of the spurs. Now,
I do know the main source being my monitor. If I rotate the monitor so the flat side is pointing at the dish, that is an obvious minimum. When it's broadside to the dish, you pick up a significant difference. So you could try that. It's not a whole no, but it's a major improvement, just rotating the monitor.
okay, well that's something to play with. Yeah, unfortunately the monitors behind me are all broadside to the dish, so yeah, I'm getting that effect to the max, I guess.
Sometimes you can change the scan rate on the monitor, the refresh rate. And if you do that, you might move the frequency as well. Yeah. It's not, you need to be set, the frequency in the monitor has to be set right, or it won't work with the video card. If you change one, you got to change the other one.
Yeah, I tried the four that were in the choices for the card that I've got and the monitors, and they just made it worse. So what I had was as good as it was going to get, so I had to leave it there. But yeah, there's four different choices, although they didn't move it around very much. Scan rate was right around 60 hertz, up and down 5 hertz or something. But yeah, I tried ferrite beads. That doesn't work very good at 1420. Apparently, it's mostly for the low frequency switching. Yeah, I'm hoping the fabric will reflect it back somewhere else a little bit, or at least give me a way of shielding some things that are radiating. So yeah, that's mostly what I've been doing. Okay.
You have any more history videos you're producing?
I don't have anything that I haven't mentioned already. I mean, I've got a lot of stuff that I'm starting to go into and try to pair it, piece it. In other words, it's got 4 different things on one 2-hour videotape, and I'm trying to go in and edit that into separate topics. So yeah, I don't have anything at this moment to upload, but you and I need to figure out how I'm going to do that, because I guess I've got more upload speed than you do. You were saying it takes a day to upload some of this stuff.
Yeah, I don't know. It depends on my. It's all internet, so yeah.
Okay.
If you can come back to me, I have some more I can tell you about, Rich.
All right, Charles, you done?
Yep.
All right, Bob, go ahead.
Yeah, I have another project that I got an idea from. I was talking to Alex about testing antennas and being able to categorize how well your antenna is. So I got the idea to build a small patch antenna that's tuned for 1420. And I have a young man that I'm pretty proud of that used to work over here on my ranch. And I talked him into going to college. He got his engineering degree, and now he's working in RF. And he's done some patch antenna design work. So I said, hey, design me a patch. And that's what he came up with. He knocked it out in just a few minutes with some free software. And I should write this up and put it out there. But we checked it with a vector network analyzer, the little inexpensive one, and you can see it's right on frequency. And so my idea is to build 2 of these, and somebody may want to shoot me for thinking about this, but actually I need to be able to transmit at that frequency briefly to do the testing. And of course, that's a protected frequency, but one way to do it maybe is in a large metal building, and there's no shortage of those out here around me with the horse riding places and things. Kind of have a Faraday cage to test in, but I have a friend that has standards for antennas, and I can get a standard gain antenna. And once I have that done, then these things should be reproducible with comparable results. So someone would be able to get a hold of a patch antenna that has a known gain, so that you could then compare with other sources that you might want to use as a reference to try to get an idea of what the gain is of your antenna. So it'd be a traceable standard for measuring the gain of your antenna. That's my idea anyway. So I would put the circuitry on the backside to do the antenna testing when you're actually testing with a source that you're creating a transmission with. And I could calibrate that to be, maybe minus 20 dB down or even lower, so that it's a fairly weak signal too as well. And these things, I believe, have about 8 dB of gain, forward gain. The patch does. Does that sound interesting?
Oh yeah.
I see a couple of nods.
Sounds like you need to send one of those patch antennas to Alex, compare with his antennas or his feeds he's been working on. That'd be a fun exercise. All right.
If I remember right, if you have the frequency and the forward gain, you can also get the beam width.
Yes, you can. Yes.
And use it as a feed.
I should also point out that this was made with one of those $150 CNC machines that you can see on the internet, to cut this out of a piece of PC board that you can order on Amazon, PC board material. And it's just FR4 060 thick, and pretty impressive that we got the thing right on frequency.
All right. What was the software you used to design that?
I forget the name of it. I'll post that in the chat in a minute.
Okay. All right. All right. Thanks, Bob. That's really good stuff. I've got a telegraph phjim@gmail.com. Who's that?
Oh, name is Jim Wilson. Good to see Jay there. I went to a science fair yesterday here in Charlottesville. They had about more than 100 projects by high school kids, and I was one of the judges. It was good to see some of their creative ideas. One girl was a brand new ham radio operator, and she was trying to use carrots as an antenna and found that it didn't work.
All right. You never can tell unless you do it.
They hadn't had the pandemic shut the science fair down for several years. So it was good to see it up and working again.
All right. Now, one thing that the Deep Space Exploration Society did was to have an annual awards for anything with radio astronomy or radios. And they basically have awarded a couple $100 gift certificates with a plaque. And what that did was that generated interest that students would start going for that award and doing radio astronomy projects. So that's been going on for about 4 or 5 years now, and it's really got a number of students. Even a couple went to state. So I highly recommend that if any of your groups is just to put out a quick award with a couple $100 for local science things. If anybody
should do that.
Well, if anybody has has a local or regional science fair that they would like to have a award for radio astronomy, and wants to go coordinate that, we will. I think we could put some kind of a plaque and dollar award value to it, but someone has to go do that and run it for whatever your local regional science fair is. So that sounds like a great idea. So anybody, just let me know, and I'll help you get it figured out. All right, Kevin and Kim and Yoda.
Good afternoon. We got snowed under this weekend, but it's been a great weekend. We've registered for the Western Conference virtually because we certainly can't fly out there. But no, when you get snowed in, you do things that you never thought you'd do. And yesterday we completed the indexing of our science and radio astronomy and astronomy library. 20 years in the making. Wow. It's going to be fascinating to go in and start reading some of those titles that we could never find before. And today we also rebuilt our Super SID receiver software, and we're just in the process of commissioning that today. Hopefully that came out okay. Hello? Yeah.
Yeah, oh, you're there.
Okay. Not sure which microphone we're using.
That sounds great.
Yeah.
All right. So since you're indexing, one of the things that Jay Wilson's going to be looking for is raffle items. So if any of you guys have books, radio astronomy books of any level or equipment that you would like to put in the raffles for the Eastern Conference, send that an email to Jay because he's going to start looking for that stuff. All right. Let's see. Anybody else I didn't get or has something to show? I went through the list of participants. All right. Well, great session, everybody. I'm going to post this online the next few days. Thanks you very much. It's been a great SARA conference session. Remember